Alright, this is a brief introduction to hydrocarbons. Hydrocarbons are petroleum-based compounds that contain chains or rings of bonded carbon atoms, and those carbon atoms are surrounded by hydrogen atoms. So let's just briefly review. A carbon atom has 4 valence electrons, so it will commonly bond in such a way as all elements will bond so that there are 8 valence electrons surrounding the central atom. So carbon will commonly form 4 single covalent bonds around it. Each single covalent bond has 2 electrons that are being shared. This is an example of the simplest hydrocarbon. It is called methane, and its formula is CH4. So this carbon has 2, 4, 6, 8 electrons around it. Sometimes carbon chains can occur, and the carbon chains occur. Each carbon in the carbon chain is bonded to one other carbon, and then they are surrounded by hydrogens. And again, you can see that this carbon here has 2, 4, 6, 8 electrons around it, and as does this one. If I finish writing the hydrogens, excuse me, the hydrogens on there. And sometimes carbon can engage with double bonds, and in this case you would not have as many hydrogens around it because each carbon atom can only be surrounded by 8 electrons. With this double covalent bond here, you have 2 electrons being shared here, 2 electrons being shared here. So 2, 4, 6, 8. So hydrocarbons contain hydrogen and carbon. They can contain all single bonds, they can contain double bonds, they can sometimes contain even triple bonds. If that is a carbon right there. I do not think this will, no, it's not allowing me erase. So here's a carbon triple bond. In this case, each carbon will only have 1 hydrogen because this carbon is surrounded by 2, 4, 6, 8 electrons. So when we're representing hydrocarbons, there are various ways that they can be seen. A Lewis structure is not typically that common. The complete structural formula is quite common. This complete structural formula is often turned into a condensed structural formula. And this condensed structural formula can then be turned into a line structure. If we were to build a hydrocarbon with the ball and stick model sets, the carbons are always black in color, and hydrogens are typically white with most model sets. This is considered a space-filling model, and every single one of these representations represents the same hydrocarbon. It is the hydrocarbon that has 3 carbons surrounded by 8 hydrogens. So when we look at this complete structural formula and turning it into a condensed formula, I'll just quickly demonstrate how that happens. So carbon chains, in this case, in this particular situation, I have a 4 carbon chain. This happens to be called butane, and each carbon, you can see, is surrounded by 4 single covalent bonds. If you're a carbon in the center of the chain, you have 2 carbons on either side. If you're a carbon on the end of the chain, you only have 1 carbon on either side, and you have 3 hydrogens. So your end carbons in these hydrocarbon chains will commonly have 3 hydrogens attached to them, and the central carbons will have 2 hydrogens attached to them if you have all single bonds. So a way that we can turn this into a condensed structural formula is to start at the first carbon. We have CH3, The next one, CH2, CH2, and CH3. And sometimes you will see this all written very close together, like as one word almost, so to speak. And sometimes you'll see dashes in there. So they're both seen equally as common. One that's not noted here is a skeleton structure. So if I were just to write the carbons, sometimes you'll see me just write carbons like this. It would look like that. Now, if you see just carbons, you have to assume some things. And one assumption is that this thing is completely surrounded by hydrogens. And also, you need to know that if it's an end carbon, there will be 3 hydrogens there. If it's a central carbon, there will be 2 hydrogens there in this situation where we have these single bonds. So this can be turned into a line structure, which would look like this. Now it's drawn in this zigzag sort of fashion, and everywhere there's a bend that represents a carbon atom. The end represents a carbon atom, and this end represents a carbon atom. It's written in this zigzag fashion because when you actually build the ball and stick models, the carbons don't fall in this nice straight line like this. They are in a ziggy-zaggy sort of fashion. Alright, so hydrocarbons can be grouped into categories, and the first is the aliphatic category, which include open chain hydrocarbons and cyclic hydrocarbons. So an open chain hydrocarbon is like the one that I just drew. Again, where you have carbons in a row after one another. Again, these would be surrounded by hydrogens. A cyclical hydrocarbon has all of the carbons enclosed in a ring sort of form. And we have, between the open chain and the cyclical, we have different categories. Alkanes contain all single bonds, and they are single bonded chains. Alkenes contain at least one or more double bonds, and an alkyne is a straight chained carbon in which there will be one or more triple bond. So with the alkenes and the alkanes and the alkenes, you can also have cycloalkanes and cycloalkenes. So a cycloalkane is a cyclical structure in which there are all single bonds. And another way that this could be represented is just with this line in a drawn as a hexagon. This represents a cycloalkane, all single bonds. Everywhere there's a bend, that is a carbon atom. Each carbon is also bonded to 2 hydrogens. In this case, I'm not going to draw all of them on right now, but there would be 2 hydrogens, so each carbon does have 4 single covalent bonds associated with it. A cycloalkene can occur where you have a double bond, one or more double bonds in a cyclical structure. In this case, there are 5. This can also be drawn like this. So this is a cycloalkene, and you see that extra line there indicates a double bond. The name of this is called cyclohexane. The hex is a prefix associated with the number 6. This is called cyclopentene. It is an alkene. It's a cycloalkene, so it's called cyclopentene. And we will have separate lessons on how to name these things. So this is just breaking that down again. I'm trying to get my pen going here. Again, the aliphatic is alkanes and cycloalkanes. So an alkane would be all single bonds in a straight chain. A cycloalkene, and I'll just make a 3-carbon cyclo structure, all single bonds in a cyclical structure. An alkene has at least one double bond, and this would be a cycloalkene. An alkyne does not exist as cyclical structures or cyclical structures, but an alkyne contains one or more triple bond. An aromatic compound contains something called a benzene ring. And benzene is a special substance that has a unique set of characteristics, but it's represented like this. It contains 6 carbons, and in this enclosed structure, this cyclical structure, there are 3 double bonds. So if I were to write out all of the hydrogens, and carbons, each carbon has 1 hydrogen. You see that each carbon is involved with a total of 8 electrons with this double bond there, 2, 4, 6, 8. And this is a model of the benzene ring with the double bonds being shown and all of the hydrogens. It's also written like this. And the benzene ring can also be shown like this. Sometimes you may see it where the hexagon is drawn kind of on its end like this. Oops-a-daisy. Yes, I just did say oops-a-daisy. I'll go to this slide. So benzene can also be seen, not like that. That one only has 5 sides. Like this, where sometimes it gets drawn with this on end, sometimes it gets drawn with the little peaks going off to the sides, and sometimes you see it with the 3 double covalent bonds in the middle like that. Alright, so that is hydrocarbons in a nutshell. Hydrocarbons are also referred to as either being saturated or unsaturated. So saturated hydrocarbons contain all single covalent bonds. And here's an example. I will draw a 4-carbon alkane, and I'm putting all of my hydrogens on. And when we say it's saturated, we say that it's saturated with respect to hydrogen, because this thing is completely surrounded by hydrogens. Every single carbon has as many hydrogens that can fit around it, and they're all single covalent bonds. If I were to draw a cyclobutane, I would have 4 carbons, and each one of these carbons would have 2 hydrogens. So this is the alkane, this is the cycloalkane. That is considered a saturated hydrocarbon. An unsaturated hydrocarbon contains at least one double bond, and let me show you what happens when you put that double bond in there. When you put the double bond in there, you no longer have as many hydrogens on the carbons that are involved with the double bond. So with respect to hydrogens, we say that it's unsaturated. So this is an example of an alkene. It has a double bond. The name of this would be called butene, which is not really that important right now because we're not learning how to name things. I'm just telling you. But you can see that there aren't as many hydrogens here compared to that. So alkenes, which contain one or more double bond, cycloalkenes, which contain one or more double bonds, alkynes, which are chains of carbon containing a triple bond, and our aromatics, which contain at least one benzene ring, are considered unsaturated hydrocarbons. So there are common prefixes with hydrocarbons, and other than briefly introducing this right now, I'm not going to spend a lot of time on it other than that brief introduction. But for example, the butane was the 4-carbon. I have to activate my pen again here. Sorry. Thank you for your patience. The butane was the 4-carbon chain with all single bonds. The cyclobutane was the enclosed 4-carbon. Pentane would be all single bonds with 5 carbons in an alkane. A pentene would be an alkene with 5 carbons. An octane would have 8 carbons. A cyclooctane would have 8 carbons enclosed. So these are your prefixes that we can see. Now, hydrocarbons can also have branches, and these branches are called substituent groups. So I'll just give you some examples. So let's say I have propane here, and the propane has, this is an alkane, and they're all single bonds. The prefix 3 is prop, which makes this propane. If I draw the condensed formula, it looks like this: CH3, CH2, CH3. If I turn this into a line structure, it looks like that. Now I'm just going to put a branch on this propane, and I'm going to say that coming off of the center carbon, there is another carbon. So what this ends up being, if I draw the condensed structure, is a CH3, CH, because this H would be coming down like that, CH3, CH3. So I see a branch here. The line structure to this would look like this. I could have a carbon chain with a branch, and that branch could contain another element like chlorine. Or the branch could be a group of elements, this right here, NO2. That's called nitro. I could have, I'm just going to activate the pen again and give you some more examples. I could have a very long hydrocarbon chain like this, and I could have a branch with 2 carbons coming off of it. So if I were to draw the condensed formula for this, remember going back to those assumptions. If it's an end carbon, there are going to be 3 hydrogens. A middle carbon will have 2 hydrogens. Every single carbon must have 4 things around it. So this one is going to have a hydrogen. So this condensed structure would look like this. CH3, and I'm going to put the bonds in. CH2, CH, CH2, 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 CH. Let me just double check. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So I do need to add a third there. And then off of this carbon right here, I have a branch that has 2 carbons. So this is the same thing. So I could put another branch right here with just 1 carbon. And if I do that, then this would become CH3. So the prefix having to do with 1 carbon is meth. So a single carbon alkane is called methane. If I have a single carbon branch, this is called a methyl group. Here I have a branch coming off of this carbon chain with 2 carbons. A 2-carbon hydrocarbon chain is called ethane. I'm not drawing the hydrogens. This is called ethane. A 2-carbon branch is called an ethyl group. And again, it's not super important that you write these down or memorize these right now. The main point is that hydrocarbons can have branches. These branches are of different types. A branch, again, could be different elements. For example, this is an amino group. NH2 is called an amino group. This is a bromo. This is bromine. So here are, on the next one, are some common substituent groups. Methyl has 1 carbon, an ethyl group has 2 carbons, a propyl group has 3 carbons, a butyl group has 4, nitro is NO2, hydroxy OH, amino is NH2, and bromo is Br, chloro is Cl. You will not have to memorize any of these common substituent groups for any assessment that I give you, and I will have a chart, or I'll allow you to write them down, and you will be able to use that as a resource when you're naming things and writing formulas. So this was a very brief introduction to organic chemistry, and very quickly recap hydrocarbons. Now I say it's an introduction to organic chemistry. Hydrocarbons really is an introduction to organic chemistry. Hydrocarbons contain hydrogens and carbons, and there are various ways to represent those hydrocarbons. The most common that we're going to see are the complete structural formula, the condensed, and the line, and sometimes the skeleton with just the C's. Hydrocarbons can be broken down into 2 groups. The one group are aromatics, which contain the benzene rings, and the other are just chains of carbons, and they may have all single bonds in chains or single bonds with enclosed structures. They may have double bonds in chains or double bonds with enclosed structures, the cycloalkenes, and the alkynes may have triple bonds. If the hydrocarbon contains all single covalent bonds between carbon atoms, it is considered saturated. It is filled with hydrogen atoms being bonded to those carbons. Unsaturated has fewer carbon bonds, and those are going to be your carbon chains that contain either double or triple bonds, or your carbon cyclostructures that have double or triple, not triple bonds, but these are common hydrocarbon prefixes. You will be able to write these down and use it as a resource. And chains and branches can have chains and rings can have branches. I didn't write an example of a ring having a branch, but here I will right here. This is a cyclohexane, all single bonds. And here I have attached to it a methyl group. Whoops, I lost it. You'll see plenty of examples of that, so I'm just not going to bother anymore. So, sorry, this was kind of rough. I have a cold, and I hope that it was helpful.